All right, now it's recording my voice. I guess I just had to restart the program. All right, so we are going to do lecture number 2. No, sorry, lecture number 1. Lecture number 1, I am going to talk to you guys today about scientific notation. Sure, many of you have heard it before. I'm going to review it extensively. It might be review. It might be like, oh, I never learned that. Or it could also just be a nice refresher because the skills could be a little dusty. The second thing we're going to learn in this lecture are significant figures. Significant figures. And I will call those sig figs for short. Have any of you guys heard of significant figures before, or you already know the rules? Biology or maybe your middle school? Okay, good. It'll be a new skill for you. We're going to learn about what an exact number is. Exact numbers are part of significant figures. And then lastly, we are going to review the rules of rounding. How do you round numbers? And a reminder for how you do that. So let's first talk about scientific notation. I'll abbreviate that SCI-NOT. Scientific notation. So for those of you, oh, by the way, in case I ever misspell anything, it's really fine. You could be like, Mrs. Vasquez, you didn't spell scientific right. I think I did, but in case I didn't, please correct me. You will not embarrass me. I'm not that skilled at spelling. And sometimes when you're lecturing, you just like get in your mind and you misspell. So please stop me and help me fix things. So scientific notation, why? Why the heck do we do it? There are really 2 reasons. So one, it's easy for huge numbers and itty-bitty numbers, like if we're trying to communicate them. So it is easy for huge numbers and I call them itty-bitty numbers, like decimals. Itty-bitty numbers. The second reason why we do scientific notation is to communicate sig figs. And when you learn about sig figs, you'll better understand what I mean by that. So to communicate sig figs. All right, so there are rules for scientific notation. Number 1, the first rule is it is always in the form. It is always in the form a, like some number, times 10 to the little exponent, right? This a right here. Okay. It is a number, so it's always a number between 1 and less than 10. So for those of you who are all mathish, you could say 1a is greater than or equal to 1, and it must be less than 10. And notice I have this little equals down there. Oh, it went to sleep. And you get to see my brother. Oh, that was when he was in Hawaii. All right. Come on. Go back. Okay. I'll have to figure out how to make it not go to a screensaver later. All right, so our A is greater than or equal to 1 and less than 10. Maybe you've heard this before. If you have a number like 0.5, that's not a number between 1 and 10. 9.99999, that works. 1.0, that's okay because it can be equal to 1.0. What it can't be is 10, like 10.0. Nope, can't be 10. It could be 9.9999999, but not 10. All right, the second thing, as far as the little exponent goes, so the B, when I mean B, I mean this little b right here, the exponent right here. So B is always a whole number when you're doing scientific notation. For those of you who are in IM3, maybe IM2, you know about, you've probably seen fractional exponents, that's fine. We're not going to ever have fractional exponents when you're using scientific notation. It's always going to be something times 10 to the whole number. 10 to the 5, 10 to the 23, 10 to the negative 16. It will never be a fraction for scientific notation. So it's always a whole number. It can be positive or negative, it can be both. And its purpose, it shifts the decimal place. How are we for visual? Are we okay for seeing this? Yeah, especially you guys in the back? Okay. So let's do just a little bit of practice. So if I gave you a number, 5,152, by the way, this is standard form. Expanded notation, it might be called. So if you hear me say expanded notation or put the number in standard form, what I'm saying is put it in the like regular number, not the one with the times 10 to the stuff. Just the regular old number. The textbook also might say expanded form or expanded notation or standard form as well. So if I were to convert this into scientific notation, would I say to myself, so let's see, let's convert this to scientific notation. Where do I wish the decimal would be? Where do I wish it was? Right now it's right here. Where's my wish? Yeah. After the first 5. Perfect. I wish it was right here. So let's make that happen. Let's just put it there. 5.152. Is this a number between 1 and 10? Yes. So now I say times 10 to the, and remember the whole point of the little exponent I'm about to put here is because it shifts the decimal place. So I need to shift the decimal place. How far did I move it to make my wish? I went 1, 2, 3. So I'm going to put a 3 there. I'm not done yet though. Maybe you've done this before, and maybe in other classes, probably math classes, you're like, oh, I moved to the left so it's positive, or I moved to the left so it's negative. I want you to try to throw that rule in the trash can. I'm going to give you something a little bit easier. So here's what you do, because you have to ask yourself this. Is it a positive 3 or a negative 3? How do I know? Well, the first step is I look at the original number. So I want to look at the original meaning this number, 5,152. So I'm going to look at that original number, and then I will decide if it was a big number or a little number. Is 5,152 big or itty bitty? Big, yeah. So positive exponents are big numbers. Negative exponents are tiny numbers. And let's not be so vague. What the heck is a tiny number? So a tiny number is anything that is less than 1.0 or greater than negative 1.0. So that's what a tiny number is. So it could be, again, 0.5. It could be negative 0.5. It could be 0.1. It could be negative 0.1. It could be 0.9999, or it could be negative 0.999. Doesn't matter. Those are what we call tiny numbers. And if it's a tiny number, then the exponent's negative. And you guys already told me 5,152 is a big number. So guess what? This is the answer. We're going to pause really quick, and hopefully I have my power cord, because it looks like my computer is starting to want to run out of juice. Yes, I have power cord. That's a good thing. I guess the next question is what plug do I use? Wow, that's bright. Yeah. Who is that? Let me see. Eric. It's not on there. Oh, that's right. He's new. He's new. And what period was it in? Was it fourth period? Will you just write him on the bottom? Yeah, that's right. Probably that paper I printed beforehand. All right, so now my computer won't die. Let's see here. What if this original number was negative 5,152, and I asked you to put it in scientific notation? What would that look like? Anybody want to take a shot at it? Bryce, you want to try? How many of you guys agree with Bryce? Give me a thumbs up. How many of you guys are still not sure if you even agree, but you're maybe? How many of you guys disagree? Is there anyone who disagrees? Maybe? You disagree? Okay. What are you thinking?
I think he's right. I just think that
I know, and that's the question, because when you see this, you're like, wait a minute, do I put it right here, or do I make the exponent negative? And that is probably the most common mistake or doubt you might have. Remember what a negative exponent means. A negative exponent means that the original expanded notation was a tiny number. Is this a tiny number? No, it's not. Tiny numbers are right here. Right? It's a big negative. Big negative number. It's not a tiny number. It's not 0 point something. Yeah. And so good. Thank you for going, is it the exponent or do I put it in the front? So you were correct. You put it in the front. All right. So let's actually try a tiny number. Questions so far? Maybe this is review. Maybe you've never seen it done this way. I don't know if math teachers have shown you this rule. I really like it. It alleviates the whole, you go left, you go right, something's positive, something's negative, and then you give up and you're like, whatever, toss the coin and I'll I have 50% chance of being right. That's not the way you want to do math, right? That's not good. You want to be always right. So let's do another example. 0.00353. That's the expanded notation. So let's put that in scientific notation. And where do you, oh, sorry, more of my family. No, let's go away, family. Oh, there we go. All right, 0.00352. Where do I wish the decimal is? If you know where you wish the decimal was, just give me a hands up. Okay, we've got most of that back table back there, yeah? A lot of this front table, a couple more people. Oh, I like these type of hands. I think, but please, and if you're doing that and you're like, I won't call them. So, yeah. Okay, let's see. Forgot your name. Tell me your name. Not yet. So where do you wish the decimal was? Yeah. In between the 3 and the 5. So we wish it was right here because then it would be 3.52. And you say, Soph, is that a number between 1 and 10? Yeah, it is. Notice how I wrote it? I got rid of those zeros in the front. We don't care about these zeros right here. They're placeholder zeros. And that would be weird to write 0.003.52, right? We don't see numbers like that. So when you move the decimal place, you just get rid of the placeholder zeros. Now we need to determine the exponent. We moved this, we shifted our decimal 1, 2, 3 places, so we're going to go ahead and put a 3. We're not done yet. We have to say, okay, self, the original number. Remember our rules right here? We got to look at the original number. So the original number was 0.00352, and that's tiny, therefore the exponent must be negative. So we're going to go ahead and make that be negative. And there's our answer. Right? What I'd like for you guys to do now is get out your calculator, the scientific calculator. If you did not get a chance to buy one yet, and you have your smartphone on you, if you are a smartphone user, go ahead and get that out too. In fact, I wouldn't mind if you have both, you can have them both out on your desk. Those calculators, you really got to get used to. If you do have the smartphone, it's with you all the time in your pocket, so you probably want to use it as well. All right, so calculator tip. Oh, does anybody need to borrow a calculator? Does everyone have a calculator, either a phone or a calculator that can do scientific notation? You need to borrow one? Yeah? Oh, check this out. Don't forget to give this back to Coriana. She's letting me borrow it. Anyone else? I do have a few more. Yeah, Anthony? So I do not have enough calculators all the time for the whole class, but I do have about 10 or so back here to borrow. Let me make sure this can turn on. Off, on. Or it could be, oh, on. Maybe the one that says O-N. Okay. Here you go, sir. And then when you're done for the day, anyone else need a calculator? All right. If you are an Apple user, and you know how you're like lay in bed and you don't want it to turn sideways because you're scrolling through Pinterest, so you do the lock screen, you need to unlock it, then open up your calculator, and then turn your phone sideways. If it's locked, it won't go into the scientific calculator. All right, calculator tip. So, you need to become familiar with a button that looks like EE. I think Apples have it, and the one, Wyatt, will you hold yours up in the air? If you have that calculator, either pink, green, black, blue, that's the one I think that has an EE. Right, Amanda? You have that one too? Some calculators just simply have an E. Find that. And it's a capital E, not a lowercase e. There's a difference. Some calculators have EXP, and some calculators have a button. You guys are the lucky ones that looks like this, 10 to the A. So here's what you're going to do. You're going to actually, let's go ahead and enter the number 5.152 times 10 to the third. What you're going to plug in, hold on, look up at the screen. You're going to actually plug this in. Then I'm just going to do the EE button. Then you're going to punch this, and then you're going to punch a 3, and then go ahead and hit equals. And it should equal 5,152. This button, I'm going to just write it in English. What it means is times 10 to the. So the way your calculator, the way you're entering, it's 5.152 times 10 to the third. But you actually enter that. So who needs help entering in their calculator? Okay, now yours. So type in 5.152. Then you have to hit second function. And then see how it shows up as an E? Now you hit 3. Anyone else? If you're an Android user, I'll do my best. Okay, this will not be the first time. If you realize you do not know how to use your calculator for scientific notation, I will help you out. My juniors in the room, you guys are going to be taking the SAT at some point this year. And these scientific calculators you can bring to the SAT. In fact, you need to bring them to the SAT. And you know there's like absolutely no cell phones, so you are at an advantage because I'm making you get one now for this class. And it's helpful to you to be very efficient with your time to know how to do scientific notation in those calculators. My sophomores in the room, you guys are going to be taking the PSAT this year, and you also can use the calculator. I'm pretty sure. My juniors, did you guys use a calculator? Okay, good. Yeah, so you bring your calculator. Again, there'll be some scientific notation stuff, and you're going to want to use that. So let's move on. So the next thing that I'd like to talk to you guys about is how do you multiply and divide with scientific notation? So multiply and divide with scientific notation. I probably should know what time we get out of here. When do we get out of here? 29? And it's, okay, I have 9 minutes. I'm gonna be really fast because this is a lot. What if I had 5 times 10 to the third times 6 times 10 to the negative 4? First of all, with your calculators, let's practice. You're going to type in 5 EE and my family. Oh, there they are. 5 EE 3. And then you'll hit the multiply button. And then you'll hit 6 EE. And then I think most of you guys, do you guys have a negative button? And then a 4. and then you want to hit equals. And try that out. And what you should get is just, is it 3? Did you get that? Yeah? No? Okay, good. I want to hear the notes. So let's practice on this calculator. Oh, you're doing times 10 here. Gotta use your E. There you go. Okay, do 5. Nope, not times 10. And now hit a Anyone else need some help? Okay, let's try 5. 6. So now we know we have to hit that thing. Yeah, okay. Anyone else need some help? Yeah? Okay, let's see. So 5. No, 5. There you go. Maybe the -4. You think that may be all right. And if you would like me to show you one-on-one as well, by the way, I will be here for lunch today. I made to let you know, today I have a school meeting at the Cerna Center. And then next Monday, I am doing the volleyball game. So I kind of screwed up because I won't be available for after-school tutoring, but lunch I will be. All right, so. All right. So I'd like for you to know how to do this in the calculator, absolutely. But I'd also like for you to know mathematically what's going on. So if I were to think about this, what I really want you to be, what is 5 times 6? 30. And then you go 10 to the third times 10 to the fourth. So 10 to the third times 10 to the -4th. That's really what's going on. 5 times 6 is 30, and then 10 to the third times 10 to the -4th. Remember the, commutative property of multiplication means 2 times 3 times 4 times 5 is the same thing as 4 times 2 times, right? You can change the order. That's what the commutative property of multiplication. If ever you remembered that, maybe you're like 4th grade math teachers. I don't know. You guys are in high school. That was so long ago that you learned that, if you ever even learned it in the first place. But basically it says when you're multiplying numbers, who cares what order you do it in? It doesn't matter. So it really is fine that we're just flip-flopping these around. I also would like you to remember, what is the rule for multiplying like bases with exponents? So, you add them. Good. So I'm going to give you the generic rule here. If I said a to the b times a to the c, what Sean said, right? Sean, nope, Gabe, you're Sean. Gabe, right? Okay, sorry. Sean's right next to you. What Gabe said is that we are going to add the exponents. You guys remember this possibly? If not, yay, you learned something new. By the way, I also want to tell you that we call this is the base. This is what we call the exponent. That way we are clear when I say base, what I'm talking about is the big number right here, 10. When I'm saying exponent, what I'm talking about is the little number up there. Okay? So now let's do what Gabriel told us to do, and we should add them. So this is 10 to the 3 plus a negative 4. So that's really just, what's 3 plus a negative 4? Negative 1. And I have to bring this down. So it's 30. 30 times 10 to the negative 1. And the question is this scientific notation? Is it? No. Why? Selma, do you know? Not sure? Why is that not scientific notation? Negative exponents are okay. You can have 10 to the negative. You just can't have fraction. Right? That's probably what you were thinking about. Oh, lots of hands. I haven't heard from you, Amanda. Yes, 30 is greater than 10. That number has to be between 1 and 10. So where do I wish the decimal was? I wish it was right there. So, all right. I moved it over 1. So I'll put a 1 there. I look at the original number 30. It's a big guy, so I'm going to leave that as 3.0 times 10 to the 1. That does, in fact, mean 30. And then I'll bring this down. And then I'll combine these. So it's really 10 to the 1 plus a negative 1, which is just 10 to the 0. What's 10 to the 0? 1. Good. So this is just a big fat 1. So really, I had 3.0 times 10 to all this junk. And the bottom line is, the answer is 3. I did all of this not because I wanted to overcomplicate it, although that's probably what you're thinking right now. It's because I really want you to understand the heart of how to manipulate scientific notation. Tonight, you guys, there is homework. Please, please, please try to do your best to get that practice done. Problem 15 and 16, actually 14, 15, and 16, you'll probably need to refer to the book, okay, to help you. Come tomorrow with questions. Have a good rest of your day. Yes.